Hello friends, hope all of you are keeping safe. Today we are going to see how to find the resultant of multiple forces acting at the same point, and this time the forces are not defined based on their angles with respect to x or y axis, rather they are going to be defined with respect to the distances. Let us go ahead with the problem. It's a simple problem. You can see there are three forces acting at a single point O. The forces are given as 106 Newton, 102 Newton and 200 Newton, and their distances are shown, and from there we are supposed to assume the direction of the force. So let us see how we can do such a problem. So here in this problem, it is a direction based problem. The directions are not given in the form of angles, rather they are given in the form of distances. So in such cases we need to find out how to find the x and the y component of the force. The idea is simple. We need to find the angle, or we need to find the cos theta and the sin theta. So if you see here, this is a triangle and we know this length is 28 mm and this length is 45 mm. So to find the diagonal, I just have to find out square root of 45 square plus 28 square. In this case, this length turns out to be 50.48. And the next hypotenuse length for 102 Newton force would be square root of again 45 square plus 24 square. This will be 48.37, and the last length is square root of, for 200 Newton force it will be 40 square plus 30 square, which will be 50. All these are in mm. Okay, now if you see, I have found out this to be 50, this to be 50.48 and this length to be 48.37. Finding sine and cosine for each of this force is simple. We know that cos theta would be adjacent side by hypotenuse. So if I define this as theta 1, theta 2, theta 3, I can say sin theta 1 will be equal to opposite side by hypotenuse, which will be 45 divided by 50.48, which will be translating to be 0.891. Similarly, cos theta 1 will be the adjacent side by hypotenuse, adjacent side being 28 divided by 50.48, which would be translating to be 0.555. Next is sin theta 2 will be equal to, again opposite side by hypotenuse. Opposite side is 45 divided by hypotenuse is 48.37, which will be 0.93. Cos theta 2 will be 24 divided by 48.37, which will also be same way as adjacent side by hypotenuse, and the value that you get is 0.496. Similarly, sin theta 3 will be the opposite side. Here this is the theta 3 that I have defined, so this will be the opposite side, that is 30 divided by 50, which will be 0.6, and cos theta 3 will be 40 by 50, which is adjacent side. Now for this theta 3, the adjacent side is 40 mm, so 40 by 50, which will be 0.8. So keeping that in mind, let us fill these values. Cos theta would be 0.555 and sin theta would be 0.891. Again, for theta 2, that is this angle, this is cos theta will be 0.496 and sin theta would be 0.93, and for 200 cos theta is 0.8 and sin theta is 0.6. So just have to multiply this force F with the cos theta to get the x component. So 102 into 555. So you get the answer to be F cos theta to be 58.83 and sin theta to be F sin theta to be 94.446. Similarly, for Fx of 102 Newton force, F cos theta would be 50.592 and Fy would be 94.86. Similarly, for 200 Newton force, Fx would be F cos theta, which is 160 newtons, and Fy would be your F sin theta, which is 120 newtons. Now the important thing that you have to notice here is the angles are not defined with respect to the positive x-axis. So these values need to be arranged according to the direction that they are facing. So here if you see, this 106 Newton force is acting like this in the positive x and the y direction. So if you see, this is the x component of the force and this is the y component of the force, together adding up to the 106 Newton. So both are positive. Coming to the 102 Newton force, the force summation would be x component plus y component. Here the x component is in the negative x direction, whereas the y component is in the positive y direction. So this has to be negative. Next comes your third force, that is 200 Newton. 200 Newton force can be put up like this: summation of this force x component plus y component, and here both the x and the y component are in the negative x and the negative y axis respectively. So both these components will come as negative. So the first part of the question we have solved, that is the x and the y component of each of these forces are calculated. Now coming to the resultant of these three forces. Determining the resultant of these three forces becomes quite easy. All that we have to do is add the x components and add the y components separately. So here if I add the x components, I would get my Fx to be equal to minus 151.76 newtons, and if I add my Fy components 94.446, 94.86 and minus 120, I would get 69.306 newtons. So my resultant R would be square root of Fx square plus Fy squared, so which will be square root of 151.76 squared, even though I give minus and the negative sign will not have any relevance, and 69.306 square, which will yield me the resultant magnitude to be 166.83 newtons. This is the resultant force, but Just representing the magnitude of the resultant force is not sufficient. We are also supposed to find the angle at which it is acting. And the equation for the angle would be theta r is equal to tan inverse of Fy by Fx. So here it will be tan inverse of Fy is 69.306 divided by Fx will be minus 151.76, which will be giving you an angle of minus 24.56 degrees. Now this is really interesting, this minus sign. All that we have to look at is what was the total Fx and what is the total Fy. If the total Fx is negative, that means it is in the negative x direction, the resultant component in the x direction is negative, and Fy is positive, so that means it lies in the second quadrant. So this minus 24 means it is measured from the minus x axis. So the actual angle would be 155.43 degrees. So when you represent the resultant, the R force would be represented as 166.83 Newton acting at an angle of 155.43 degrees. This is your final answer. Thank you for listening to the lecture. I hope you are enjoying my lectures. Please leave your feedback in the form of comments in the below section. It will be great to hear from you so that I can improve my coming lectures. Thank you.